Hey everyone, welcome to 197 Concepts. So in this video, I will be telling you how to interface LCD display with the microcontroller 8051. See, 8051, or you can say it as 8051, is a very basic microcontroller. And when it was being developed, it was developed as 8051. But after some advancements, when there were multiple companies for the development of the processor or for the manufacturing of the controller, not processor, controller, at that time we have got the multiple, what we say, multiple types of microcontrollers within the 8051. So that's why when you observe the microcontroller, we generally speak about 8051, but when we go for practical implementation, we just use 89C51. Okay, now so 89C51 uh, is the advanced version of 8051, and since the 89C51 that we use in practical implementations was developed by the company Atmel, so the name is 8089C51. Okay, and LCD, you are familiar with LCD, it's a liquid crystal display. And I believe there is no need for the description or for the introduction of LCD display. You might be very familiar with the LCD. So LCD stands for liquid crystal display, and you might have seen these in calculators and all. Nowadays in calculators, before it was used in multiple things, and in today's world, after the development of LED or OLED screens and all, after the development of LED screens, LCD is not commonly used. It is used in budget-friendly devices. So you will be familiar with LCD devices or LCD thing. So just Google it once, you will get to know. And when you see the image in front of me, this is the LCD. Just let me activate my pen. So yeah, this particular box is the LCD, and this is your 89C51. Okay, so microcontroller, and you might be observing here all the D0s to D7, RS, RWE, and VEE, VDD, and VSS. Okay, so structurally the seven segment, not seven segment display, the uh, LCD, liquid crystal display, seems to be like this. Okay, and microcontroller, you're familiar with this. And now coming to the descriptions of the pin. So 805, not 8051, this LCD is a 16 by 2 LCD display, liquid crystal display, that can handle up to 8 bits only. So this 8051 was mainly developed for 8 bits data, only for 8 bit data, and hence the LCD is able to handle only the 8 bits. That's why you see here the total of 8 bits. So these 8 bits are represented from D0 to D7. That's these 7 bits. Now you may ask me, what is this VSS, VDD, and VEE? So VSS is nothing but your ground connection. It is used for negative power supply, not negative power supply, it is used as neutral, whereas VDD is used for positive power supply. Okay, it's positive power. And finally, VEE, it is connected to a potentiometer. It is connected to a potentiometer to differentiate, to increase or decrease the brightness of the screen. Okay, now if you press the brightness up button in the laptop, the brightness of the screen will change. In the same manner, here also, when you connect the VEE pin, not all the pins, only the VEE pin. Okay, so that is pin number 3, which is visible here. If you connect this pin to the potentiometer by rotating the knob, you can easily vary the brightness of the screen. So since we are not connecting a potentiometer here, there is no need for us to change the brightness of the LCD display, as it is virtual setup. We are just connecting it to the ground. Okay, and the very main important pins are nothing but RS, R slash W, or else RW, and the final one is E. Okay, so RS defines register select. So what is this? I will tell you later. Then RW is read or write. Read or write. So even this one will be explained later. And enable E is nothing but your enable pin. So you might be familiar with this enable pin. For every electronic device, enable pin is must. So it's very commonly used. And in order to send the data, in order to write the data into any particular device, you definitely need this pin, enable pin. Okay. Now let's go to the program. And there I will explain these three pins, RS and all. Okay, so I need a shortcut here to delete this, minimize this. So now you might be familiar with this circuit. I will show you the output once in the prototype, but only after the explanation of the program. So yeah, this one. Now, if you observe the program here, it's a bit lengthy. If you observe the program, it's a bit lengthy. No need to worry. You just have to be familiar with the what we say, you should know how you are going to how your program is going to work. You should be familiar with the logic. That's it. There is no need to worry at all. So here we are. I'm going to explain the program. Let me take pink color. Right. So before going to that program, let me explain you what is the meaning of RS, what is the meaning of RW, and what is the meaning of enable. Okay, so enable, it is used to activate the device, to activate the LCD display. Okay, RW is used for either for reading or writing. So mostly it is used by the LCD display to read the data. So it will be like this R slash W bar. And this one generally we are going to send logic one. Logic one. If this is logic one, definitely W bar will be zero. So that means your LCD is going to read the data, not write the data. Now, what is the meaning of read? See, if you consider this as a device, if you are taking data into the device, then that is a read. If you are taking data outside from the device, then that is the write function. Okay. Now, this can be a little bit confusing because what is, if you take 805 and here or any microcontroller or any master device, what is write becomes the read for this device, and what is read becomes write for this device. Let us consider this as an LCD. Okay, so there's a huge confusion here. So what you have to do is you have to always consider the case or the scenario of the 8051. Now, if you take the scenario of 8051 and I have a LCD here. Now, when I'm writing this data, okay, when I'm writing this data is going to be accepted by the LCD. So always that should be read because there is no return from this LCD to the microcontroller that becomes the write of LCD and read of 8051. There is no such case. There is no return signal in the LCD. We are having only a forward direction signal that is from microcontroller to the LCD display. That is why there is always a write function, but this write pin has to be connected to the read pin of LCD. Okay, so always we are going to write or we are going to send the logic R slash W, or else you can say the RW pin, it's always logic 1 because it's R slash W bar. It's a complement of the other. So that's why we are always reading the data into the LCD display but never writing it back. There are some conditions, but those are very specific conditions. For this program, there is no need to write a signal or write data from LCD to microcontroller. That's why we are always going to keep it as logic 1. Now, the next pin. The next pin, the most important pin is RS, which is the register select. Okay, register select. Now here the important thing is you are for an LCD you are sending the data. Okay, you are sending the data at the same time you are sending some commands too. Okay, now you might ask me what is the command. See, uh, your LCD that you are using here is a 16 by 2 LCD. That means you have 16 columns. Okay, if you take this LCD, vertical lines, totally there are 16 lines. Okay, and so on up to 16 lines. Vertically, there are 16 lines, and horizontally, there are just two rows. 1, 2. That means I have 16 columns and 2 rows. Now, if I want my cursor to this position at the starting position, if you take the LCD and you want your cursor to be here, it is the first column and first row. Okay, so for this, you have a specific command. You have a very specific command. And when you send this command, your LCD is going to be confused between whether you're sending a command or you're sending a data. Okay, so for example, if I want to select the first row and first column, the intersection point of the first row and first column, let us assume that it is just 0, 1. It's not the right one. I'm just saying for an example's sake. So it's 0, 1, and you send this using a microcontroller to the LCD display. Now, this 0, 1, it can be a number or it can be a command, right? CMD. It can be a number, okay, for just like 1 plus 2 and that mathematical number, or it can be a command. So in order to differentiate that, you are going to use this register select pin. So it all completely depends on this register select pin. You are going to send the data, you're just going to send some information. It can be 0, 1, it can be 0, 2, it can be 0E, it can be C0, or it can be 0, 0, it can be what are there, C0, it can be C5, everything. It can be anything. Now, this C5 or C0, whatever you are sending, either is it a number or is it a command? For this clarification, the LCD is having the register select pin. So, if this is logic 1, you are selecting the registers for the command. Okay, what you are sending the information is the command, and if this is logic 0, it's just the data. Okay, so that's the main thing, or that's the main important things you have to know for the better understanding of this program. Also, what I am thinking of the logic is, whenever, so if I take this microcontroller, okay, this is interfaced with the what we say command lines, CMD command lines and data lines. Not command lines, it's those are called as control lines. Okay, so what are those control lines? See, data lines, data lines are from D0 to D7, whereas all the control lines are just three. Those are register select and read slash write and then the enable. Okay, so there are only three lines. This is the data lines. So control and data lines, and this is your LCD. Okay, so my information is my plan is, if I need to send a character M, if I need to send a character M, after, of course, after initializing the LCD, I need to send the character M. I will just type a letter M, and then I will call the control lines in order to uh, accept or inform the LCD that what I'm sending is not the command, it's data. You have to read it, and then finally I'm going to enable it. Okay, so that's the control lines and data lines. And after enabling these lines, I'm going to send the corresponding ASCII codes, ASCII codes via these seven data lines. So this conversion is not necessary. We should not, we are not responsible for this conversion. Okay. So this conversion will be carried out by the 8051 microcontroller itself. So that's the main logic. And now when you come to the program, before going to the program, I need to show you something. So if you see here, this I'm going to share this link in the video. If you look at this table, so these are all the basic tables or all the basic commands that you are going to use while interfacing the not seven segment display, while interfacing the LCD display. So for example, you are having the 01 command, and you are having the 0E command, you are having C0 command, 80 command, and I believe 38 is also there. So these are the commands that you are going to use. This is used for clear the display. So you will get a better understanding when we go into the program. Okay. So this is display on and cursor blinking. This is the first line. There I have told you it's 01 for the first intersection point of a vertical line and a row. So actually it's 80, not 01. 01 is used for clearing out the display. Okay. So this is the basic table. Just look at it once. It will be in the description box. Okay. And this is the main thing. And I will just refer to this table when I'm explaining the program. So yeah, let's go to the program. Where is it? Notepad. Yeah. Here. So the very first thing, let's go to the word. There's a constant shifting between these two. So it will be a little problematic. Yeah, while I'm using that pen. Okay. Let's change the color to orange. No, orange is not that visible. Yeah, this is much better. So see here, when you observe here, the very first thing is, of course, okay, the very first thing is, of course, you have to, originate with the 00 register. Okay, you are just clearing out all the memory that is present in the 8051, and here what you're doing is you are moving the number 38 to accumulator. Now why is this used? Accumulator is just like now I have told you, if this is your microcontroller. Oh, it's not writing there. If this is your microcontroller, you need to send it to the LCD display. Then you have to send the number 38. First of all, that number 38 has to be stored into the accumulator register, because when you use the command move, or when you're using the control lines, the very basic place where the microcontroller is going to search for data or information is the accumulator. So that's why the number 38, though it is a command, it is stored in the accumulator by default. And then we are just this com and delay, these are nothing but just the sub functions of the program, where even this my data also. So where you are using the control lines, we are controlling the control lines in order to define whether the information that you are sending, that is 38 or m or p or c, whatever it is, whatever information that you are sending, whether it is the command or data. Okay, so command com is used to manipulate, to change the control lines in order to inform LCD that what instruction or what information I'm sending is nothing but a command. Whereas the uh, why is that my data, as the name itself defines, my data tells the LCD display that whatever information I'm sending from microcontroller is nothing but uh, data that you have to display. Okay, So that's the difference between these two, and definitely I will explain those, but not right now. Uh, so those will be explained. Yeah, this is a little bit problematic. Okay, let's go back to Notepad. This is much better. Uh, so I will be explaining when I will be explaining those two sub logics when those come at the program. So if you observe that, it's at the bottom. Okay. So delay is just to create a delay. This is the my data that is used to send information to tell the LCD that whatever information I'm sending is nothing but the data, and COM is nothing but the clarify the LCD that whatever information I'm sending is nothing but a command. Okay. Now, when you come to the program, the very first line is not this one. Yeah, this will be much easy. So when you come to the program, the very first line is move a comma 38. Oh, that's too much of thickness. Yeah, yeah, this is better. Okay, the very first line is move a comma 38. So if you search the 38 in the table, it's two lines and 5 by 7 matrix. What this defines is two lines, 5 by 7 matrix. Now this 5 by 7 is nothing but in what format you're going to show or what format you're going to display. For example, this character M is going to be used, it's going to be displayed by using a 5 by 7 matrix. Okay, so no need to go in depth with this. That's a complete different matter. What you have to focus is what's the meaning of two line. See, our LCD displays 16 by 2. Okay, so 2 means two rows. So that's what I'm telling my microcontroller. So, or the LCD, what I'm telling is activate your two lines activate your two lines in the LCD display so that I can use it accordingly according to my wish. So that's the main meaning. And when you come to the next point, when you come to the next immediate line, that is a call command and a call delay. So here I have not used the function data. Okay, subroutine my data, because the number 38H, it is nothing but the uh, information that is used to control the LCD display. Okay, that's that's why what I have called is a call command function, command subroutine function. Okay, so you will get a clarity what is this when you go for that particular thing. Okay, and delay, you are very familiar with this. It is just to create some delay. Those are just some loops. Okay, so the next section is hash move a comma hash 0 eh. Now when you go for the 0 eh, that is nothing but display on and cursor blinking. So you are going to light up the display and you are going to just blink the cursor. The next similar, call for the command and call for the delay. Next, finally, is clear out the display and then call for the command, call for the delay. So when you call this command, okay, when you call this function, there will be nothing but control lines like RS, RW, and enable. So E. When you send this immediately, it's going to it's going to depend on this RS register select pin, and based on its logic, the LCD can define that 0 1 is nothing but it's an information. Of course, it's an information, but it's not a mathematical value. It's some command. It's some instruction that is linked to some other function. Now, what is that function? It will be looking for this table. So where is 0 1? Here. So clear this display screen. So it immediately what it does is it just clears out whatever information it was displaying previously. Okay. So now the next move a comma 0 ah. So this is nowhere in this table. So this is nothing but you are just selecting the second row, not the first row, the second row of the second column of the first row. So yeah, if you observe here, this is my data and delay. Here, what you are doing is you are not sending this as the command, you are sending this as information. Okay, but due to some syntax errors, if there are no syntax errors, due to some logic errors, this is working but not in a proper manner. Okay, actually I should have deleted this. Just leave it. Now, the very main important line, move a comma hash ATH. So this tells that select the first row, not the second row. So there are two rows, the first one and the second one. Select this row, and after that, all my data is going to be pushed into this row. Okay, so that's what I'm telling. Move a comma hash ATH. This means you have to select the first row. Okay, then what I'm doing is I'm just simply passing out my data m p m p. So basically what I'm trying to display is mp mc lab. So this is what I'm trying to display. That's why, of course, you can do it as a string also. That is for some other video. I will share. I will explain that also. But what I'm doing here is I'm individually sending M. I'm individually sending P, again M, and again C, and then L, A, B. So this comes under first row. This comes under second row. Okay. So first row, to initialize the first row, the command is ATH, and to initialize the second row it is C0H. Yeah, you can see here C0, force cursor to the beginning of second line, so that is C0H. Okay, so that's the basic idea. And I believe that there is no need to explain all this, because after sending the each character, you have to tell that LCD that whatever I'm sending information is not a command word, it's just a data that you have to display, and we should give some time for it to analyze that information and carry out its command. So that's why, for after every passing of the character by using and calling the my data, we are just creating a delay. So that will be up to this section. Okay, so that's m p m c. Okay, now when you see this, when you see here, I'm completing MP, MC. So the first row is completed. Now I am going for the second row. There I have to display LAB. That's why before going for the character display, I'm just sending a command that now you have to initialize the second line, or you have to select the second line or the second row. That's why I've used the command 0C 0H. So H means hexadecimal. So 0C 0. That's why I've used this the 0C 0 command. Okay, then I'm calling for the command. Yeah, I will show the difference. The difference is nothing but your register select pin. That will be the main difference. I will show it in below. Okay, then I'm calling for the delay, and then I'm going to pass LAB. Now if you observe this, I have passed these characters like this. So MPMC is all caps, and lab, out of lab, A is small and B is also caps. So this is intentionally kept this way in order to tell you that the LCD display can display both capital and small characters. It is case sensitive. Okay, so it is case sensitive. If it is not case sensitive, then even the small a would have been displayed as capital A, or capital A would have been displayed as a small a. So for small a you are getting small a, and for capital A you are getting capital A, means the LCD is case sensitive. Okay, but it can display both the things. That's why you are having ASCII code. Okay, so if you observe here, you are sending L, A, P, and all the three lines are my data, my data, my data, delay, delay, delay. Okay, so no need to, I believe no need to explain all that. And finally, what you are going to observe here is SJMP and SJMP same. This is just to create some loop. Now, the main program, not the main program, the main part of the program. This delay, if you observe here, delay, it's nothing but, let's go first for the delay. It is easy to understand. Okay, So this delay, I'm just moving, I'm loading R3 with 10H value and then R4 with 250 value. And then what I'm saying is DJNZ. So this means decrement and jump if not zero. Okay, so let's go with an example. R3 is loaded with 10. So this will be compared with zero values. So how should I show you compare? Uh, yeah, I will write CUMP. Compare with zero. So since 10 is not equals to zero, so what I'm going to do is I'm going to decrement this. So 10 minus 1, which is equals to 9. And this, since it is not equals to zero, what I'm doing is I'm going to jump next to the label here 1. So I'm going to jump here. Okay. Now again, this 9 is not equals to 0. So again, this is going to be decremented to 8 and it is going to jump at here 1. How many times is up to 10 to 0? When finally you get a 0, you are going to compare it with the value 0. Since 0 equals to 0, there is no need to decrement and there is no need to jump. It's the same case for this one and for this one. Okay. Just the difference is for this line, it's for R4, it's going to start from 250, like 250, 249, 248, 248, and so on up to 0. For R3, it's just 10 to 0. Okay, that's the only difference. Now, the main section. So if you have observed here, what I'm doing, I'm assigning P 2.0 to RS pin and P 2.1 is for read the write pin and P 2.2 for enable pin. In this manner, you have to connect to the circuit also. Okay, so be careful. You can assign other pins also, that's up to you. But I'm selecting P 2.0, P 2.1, and P 2.2. Now, keep in mind CLR means clear and set B means set bit. Okay, so CLR, whenever it is executed, you're going to get a logic of logic 0. I will write here L0, logic 0. And whenever you're going to execute this command, this is logic 1. Okay, that is logic 1. So now when I say CL P 2.2. Oh, yeah, this is not the correct P 2.2. This means clear out the pin or send logic 0 to the pin 2.2. I'm I don't I don't consider the value whatever that is present in logic 0. If it is P2.2, if it is already at logic 1, I'm not going to consider this. I'm just going to overwrite it with the logic 0. Or else if it is already 0, then no, then even then also I'm just going to overwrite with logic 0. Okay, that's the meaning of CLR, and it's the same for set B. It's a little bit opposite. The process is same but opposite. Okay, so clear means sending logic 0, set B means sending logic 1. Okay, so that's the main thing. Keep in mind, based on that, your complete program is dependent. Okay, now when I need to send a command, what you are doing is you are just clearing the RS pin. So if RS is equals to 0, that is whatever information you are sending is command. If RS is equals to 1, then all the information that you are sending is nothing but a data. And since you are already always reading data into the LCD, it should be always at logic 0. It should not go for logic 1. And enable should always be logic 1. Because only when you are enabling the device, when you're triggering out the device, only then the register select is possible and the read function is possible. If I'm going to keep enable at 0, then there is no use of sending read or write and register select. That's why enable pin should always be at logic 1 and read pin should always be at logic 0. Okay, now you can ask me, you can tell me, sir, if it is that necessary, you can directly connect it to the power supply and you can directly connect it to the ground. R can be directly connected to ground, whereas enable can be directly connected to 1. Be careful and be mindful. I am sending this data voluntarily. I don't want these two particular pins to be always on or to be always off. I just need them to be on and off when I'm sending the data. Other than that, I don't want them to be on, to be permanently on or to be permanently off. That's why for every information that I'm sending, every byte of information that I'm sending, I am activating those lines with the specific logics. Okay, so that's the main thing, and you can see here it's clear P2.20, that is a read pin. So I'm setting it. I'm sending, since this is a command section. This particular section deals with the information that send whatever information I'm sending is command. Okay, so this section deals with that part. That's why the read register select should always be 0. So register select means it's going to, for controlling LCDs, just like SCON, SBUF, TMOD, TCON, there are some specific registers. So you don't need to know those. Just keep in mind, in order to send the information into those registers, configurable registers, we are selecting the RS pin to be 0. Okay, if that particular pin is at logic 1, that means don't need to configure the registers, you just need to display the information. Okay, and that's why I'm writing here clear P2 2.0 and clear the read pin, and then set the enable pin. Then I'm calling for delay, so delay just to give some time to carry out these functions. Then I'm passing the data accumulator into P3. So if this is my microcontroller, I cannot directly pass the information. Okay, so I have to definitely pass the information only from accumulator. So that's why, that's the main reason. At the starting of the program, you might have observed move uh, a comma hash 0c0h. Okay, so I cannot move this command directly into the LCD. This has to be moved into accumulator, and the accumulator has to pass this, okay, via specific port. And that specific port, what I'm selecting here, is nothing but my P3 port of the 8051. And finally, what I'm doing is I'm clearing out the P2.2. So P2.2 is the enable pin. So you can observe here, I'm turning off the device. Okay, I'm not triggering it after successfully sending the data. I'm just turning off that device. Okay, for that I'm using clear P2.2, and then I'm just telling my program to return to return its to return itself to the previous line, or for the execution of next line. Okay, and in the same way my data is going to be executed. So only difference between that and this is, the only difference between the command and my data section is, just if you observe here, it's just the T2.2, this register select line. Okay, so if you see here, say CLR 2.0 is 0 initially, and here it is set B. That means I'm sending it to logic 1. Then P2.1, P2.1. It's clear and it's clear. Then P2.2 will be set, P2.2 will be set. Finally, after sending the data, P3 comma A, after delay function, I'm clearing out the P2.2. That means I'm just closing out the device. Okay, that's the main program. That's a complete explanation of the program. Now let's just try this out. Okay, so this is the circuit diagram. Let me try this. And so for that, I'm just going for Keil. So this, I'm opening up the program. Okay, yeah, this is already typed out, but for just showing up the procedure, I'm going to start from the starting process. So project, new microvision project. And I'm going to store it on the desktop new folder. That's 8051 LCD. Okay, enter it. My project name is 8051 LCD. Yeah, the processor that I have to select is Atmel 89C51. Select it, click on OK. Click on no need. So expand this, you will get source group, and at the source group, right click on it and then add new item to group source. Since I'm going for assembly language, it should be asm.s, and the type of the file, it is by default selected by selecting on this. So if you go for C, your extension will be .c. If you go for ASM or C, C prepost .s, so extension is same, but this is some different file. Header file is .h, text file is txt. Okay, so we need assembly language file, so .a51 and 8051 LCD. I'm just going to add it. So where you have created the project folder, there itself you are going to store this program file, script file. We call this as script file. Okay. So just select on add and expand this, you get the 8051. If you close it here also and double click on this, you get the same file. Okay. Now go to Notepad, Control A, Control C, and here control V. That's the complete program. Okay, now I'm just simply going to build the target. See, observe here, I have not changed the frequency of the processor and of the controller and all. I'm just going to build the target. So no syntax errors. If there are some syntax errors wantedly, I'm just removing that and I'm going to build the target. Okay, so yeah, that even that did not give it, so it has understood with the letter of, yeah, for the character. Let me remove just one quotation. Okay, see, it has told that 8051 LCD.A51 at the line of 21, you are having missing string terminator. So what type of error? The error number it is giving A2, and the type of error is it's defining. So at the line 21, I have just missed a quotation. Yeah, if you give double quotations, let's see this. Yeah, it's not a proper way. So definitely you have to give a single quotation and then build the target. That's it. Okay, so that's the thing you have to do. So this building the target will tell you all the syntax errors that are here present in the program. It will not define any kind of logic errors. It will just tell you only the syntax errors. Okay, now what I'm going to do is I'm just going to Proteus. I'm going to Proteus. I've opened it, new project. Yeah, after selecting the new project, I'm just going to select the 8051 folder that is present on the desktop. Select it, and in that 80 8051 LCD. Enter. Do nothing, just click on next, finish. This will open this here. Okay, go for select the components mode here, components mode, and click on the pick devices, and then search for 8051. If you search for 8051, you're going to get this multiple things. So these are the capacitors, different types of buses and all. So these are the capacitors. It's just better to search for 89C51. You will get the exact microcontroller. Select that, click on OK. Place it by just a left click. Okay. So you can see here port 0, port 2, port 3, port 1. I've used 2.0, 2.1, and 2.2 for the control lines, and port 3 for the data lines. Okay. Again, I need the LCD display. Pick devices and search for LCD. So there will be multiple LEDs. So this is LM016L. This is 17L. So these are just different varieties. Go for 16L. So this is 16 by 2, 16 characters by 2 rows. So 16 columns and 2 rows. Okay. So this one more where it's 16 columns and 4 rows. Is it? Yeah, it's this one. So this is 41, 14, 16 by 4. So description is written here, 16 by 4. That means 16 characters, 4 rows. Okay, 16 characters vertically, top to bottom. It's that each line will display, each column will display one character. So 16 characters across and 4 rows top to bottom. In the same manner, so this one is 20 characters across and 4 rows top to bottom. Okay. So I'm just going for LM016L. Click on OK. Just place it here. Okay. And the very first thing that I'm going to do is I'm just going to arrange this. The very first thing that I'm going to do is I'm just connecting the control lines. You can just click on it and you can drag it. So for 190 degrees rotation, it will just take it. All the 8 pins, I'm just going to connect it. Okay. So you can connect it this way also. If you need a neat way, what you can do is you can just go for the terminals mode and select the default and place it. Okay. So this thing, this label tells us that you don't need to completely place the line. This tells that your line is going to be connected from here to here. Okay. For that purpose, you have to place four connectors. These are just like the connectors in a flowchart. Okay. So you have to place these four connectors and then you have to connect this. So connecting them is not a big deal. Connecting them is not a big deal, but you have to name them properly. So I'm just giving the line name D7, D6, it's D5, and this is D4. So this will tell, so this is D4, this is D5, this is D6, and this is D4. Oh, not D4, it's D7. Okay, so this tells that the line from PT 3.4 is coming out from here and it's going to connect towards this line. So this complete section, this visible line is not necessary. That is purely for aesthetics. It's up to you whether you want to use the label or whether you want to use the line. So both are possible. I'm just what we do is let's just remove these and place this with the labels and be careful while labeling it. Okay, so let's keep it in this way. So I'm going to use labels. This particular thing is called as label. Okay, so I'm going to use labels for the data or information for port 3 and I'm just going to use lines for the control lines. Okay, now when you come for VDD, VE and VSS, of course VSS and VEE are going to be grounded. So just short those two and select the ground here from the terminals mode, place it there and easily connect it. That's it. That's it. Okay. Now you need a power supply. So select the power supply from the terminals mode, connect, take that apart and then easily connect it. That's it. Okay. So now if you run this, LCD is going to on, but nothing is going to display because we have not told the microcontroller what to do and what not to do. So for that, you need to create a hexadecimal file. For creating a hexadecimal file, you have to go back to your Keil project. Okay, there at the target, select the target, right click on it, and options for target. There, this you might have you might be familiar here with this part for changing the frequency in the video of serial communication. Okay, so here do not touch this XTML. Keep it that way. Keep it 24 itself. No need to change that. Go for output and create hex file. So since we are doing it virtually, there is no need to change this particular frequency. If we are going to do it in the hardware, if you're going for a physical circuit, definitely the program what you are typing here, its frequency, the program's frequency and the frequency of your kit has to match. Otherwise, the you won't get the output. Okay. So since it is just virtual, no need. So check mark on this. Go to the output tab and check mark on this. Create hex file and click OK. Then again build the target. So it has created a hex file. Now go to your Proteus circuit, double click on this. So see, observe here, no program file, and observe the clock frequency 12 megahertz. No need to change. Keep it that way since it is a software itself. So no problem. Click on browse for program file. Click on browse and go for desktop where you have stored the your project file of key. So 8051 LCD, there, go for the objects folder and LCD hex file. Click on it, click on open, and then finally, OK. Now run it. So see, that's my output. So MPMC lab. Okay. So since the delay is very small here, go back to your software, your program, and delay after it's just 250. I'm going to increase it by 2500. So let's keep it that way. This one I'm going to keep it on 100. Again, I'm going to build the target. Okay, value has to be truncated to 8, so it's line number 75. Let's keep it for this, and I'm going to increase this. Let me see it once. Yeah, it has to be truncated for 8 bits, so that's a maximum error. Yeah, this thing I can change it, right? What about 500? I think it takes 500. No. It was 250, right? Let's try with 35. 77. It's only going for 250. Okay, due to some logic errors, it's only accepting 250. Okay, so because of that, I'm not able to show you the. We can do it one more thing here. I'm just introducing a new delay. Okay, so that's what I've done. I built the target. Now I'm going for Proteus, and now if you see here, that's a huge delay. Here we have to wait for the output now. No, this delay is too much. I will go with 50. Yeah, hex file is created. No, even 50 is also a huge delay. Yeah, let me try this one. 79 here. Yeah, I've not used this. So that's a syntax error. Yeah, okay. Okay. So it's just the delay process. So after introduction of that one particular segment, it was taking a lot of time. So I've just removed it And that's it for this video. I hope you have understood the program, the logic behind interfacing of LCD with the 805 and microcontroller, and hope you have understood the circuit diagrams also. Okay, that's it. Uh, Thank you.